Hi, and welcome to the Frog Pond School of Design. Today I want to talk about concrete, of all things. Now, concrete is the single most common man-made material in the world. That's probably not a surprise to you if you think about it. And the fact is, it's not even close. I don't think anybody's ever even tried to figure out what's number two. But it's got an interesting history. It's been around for a couple thousand years. The Romans used it, and there are a lot of things that's fun to understand about concrete. First off, it's concrete. It's not cement. That's one of my pet peeves when people refer to concrete as cement. That's like referring to a cake as flour, because that's a pretty common comparison. Cement is to concrete as flour is to a cake. So it's an ingredient. It's a primary ingredient, but it's an ingredient. Technically speaking, even asphalt pavements are concrete also because they're asphaltic concrete. But what we're talking about is Portland cement concrete. It's called that because the binder is the cement is Portland cement. And that's made from ground up minerals that are fired in a kiln. And somehow they discovered that when they wet that, it solidifies again. The interesting thing, really, though, is that over the centuries there have been improvements in the material, but nothing like the last, say, 50 years or so. It's just incredible what's happened in that time period in terms of admixtures, things they put in it to perform its or to improve its performance or its workability, and in the production, how it's made, and very recently having to do with improving its sustainability. Again, it's a very heat-intensive process making the cement itself, so everything they can do to reduce that impact on the environment is really important. They have succeeded in doing a lot of that by using alternative firing material or products, more efficiency in the firing that reduce the use of fossil fuels and reduce the production of CO2 in the process. Actually, they've reduced that up to about 30% in the last several years. They also are looking at alternative materials for making the cement itself that reduce the amount of mining that has to be done, and then to a greater extent, the aggregate that's used. They're looking at lots of other materials there to reduce the amount of mining that's done. They're also looking at sourcing this stuff closer, because that's one of the great things about concrete. The materials that it takes to make it are everywhere. So if you find those materials closer, you've reduced the transport issues, fuels necessary for that. So all these things being considered, the concrete folks are working very hard at improving all that. They're looking at, or they're actually using slag from blast furnaces in the steel industry. They're using ash from coal-fired power plants, various things going on there. But in my mind, some of the most interesting improvements have to do with improving the performance and the workability of the product with admixtures and other things they're doing. Fiber reinforcement is being used to strengthen the material. Concrete's a beautifully strong material in compression, but it doesn't have a lot of tension strength by itself. Then that's why beams have steel rods in them to provide the tension support there. But you can give the material itself more strength with reinforcing with fibers actually cast into the material itself. They're using a microsilica material now to increase the density of the material, which reduces the porosity, which makes it more appropriate in certain situations. The one I find the most fascinating is the development of plasticizers. They, I think, call them water reducers. An interesting aspect of concrete is that when it sets, when it hardens, that's not a drying process. That's a chemical reaction that's taking place there. You take the Portland cement, you add a little water, and that sets off the chemical reaction. You can seal this up as tightly as you want to keep air away. It won't make any difference. It's going to set up regardless. So you have to add the water, which also makes it more workable in the field. The problem is it doesn't take much water. And if you add more water to make it more workable, you actually start sacrificing the strength of the final product. But now they've come up with plasticizers. You pour just a little bit of that stuff in there, and it flows beautifully, which allows them, for one thing, to pump the material rather than just run it down the chute out of the ready mix truck. They can actually pump it like a slurry some distance. It levels itself. It's way more easy to take care of, and they haven't sacrificed the quality of the final product with that. Obviously, they've been adding coolants and antifreeze and all kinds of other things for a long time. But the bottom line is the single most common man-made material in the world is getting better and better. It's becoming more sustainable, having less impact on the environment. It's becoming easier to work with, and the final product is getting better and better all the time. It's just amazing to see something that's been around that long and that basic material find so much room for improvement. So thanks for joining us today on the Frog Pond School of Design. I look forward to seeing you hanging around the pond again real soon.